Hi everybody, this is Mark Weitzman, and welcome to my YouTube channel, Theoretical Physics with Mark Weitzman. Today I want to do a weekly blog. I guess I should call it a monthly blog, but I've been quite busy lately, traveling, summer vacation, a couple of weddings. So today I want to talk about some recent things I've encountered on physics and maybe some things that some of you might be interested in. Today I watched a pretty good video. It's a standard. David Gross, who won the Nobel Prize for along with Wilczek for QCD, discovering various aspects of QCD, asymptotic freedom, infrared slavery and everything. QCD is a great theory. This is it's about 50 years ago that this work was done, which was about 1 year before I entered college and started really studying physics. I remember in 1974, the November Revolution, when the J-psi particles were discovered and everything. I remember that, but I don't remember the 73 work on QCD. Probably I hadn't even heard of QCD back then and was just like reading the Feynman lectures. But I highly recommend this video. It's an hour and 47. And he covers a lot, very non-mathematical, but he covers a lot of like the history, and the future. So this is a pretty good video. I remember it. I recommend watching it. And then speaking about 50 years ago, I do remember this. Gravitation was published 50 years ago. It's been republished in 1917. And it has a new preface and a foreword. The preface is very good because it tells you what's still valid in the book and what needs to be updated, and it gives you references where you can update. But I decided to reread this book, and I'm reading like about 1 or 2 chapters a week. I had recently gone through chapter 41 on spinners, because that was a chapter, when I read this book, I was a senior in high school, and I hadn't had a quantum mechanics course yet. So there are certain things which I wasn't that mature at the time and ready to read, and one of them was on chapter 41 on spinners. So I went through that about a couple of weeks ago, and I did all the problems, and it's fairly easy. If you've done quantum mechanics, you'll find no difficulty in doing it. But it does introduce some of the notation in four-dimensional spinner helicity formalism and everything. So it's worthwhile. But so I'm going to go through this book. As I said, this is not my favorite book on general relativity. As a matter of fact, I prefer Weinberg's book, which was written at the same time. But there's some good aspects. And the thing about this book is that it's very wordy, but it's easy to read and everything, and the problems are fairly easy. It has a reputation of being difficult, but I really don't think that's the case. And if you want, like I said, this preface, you can get the preface online. There's also a foreword by David Kaiser about the history of the whole book and everything. That's also available online. So this is, I don't usually reread textbooks because my philosophy is, if you're going to want to learn something, get a new that you already know, and maybe you want to review it, get a new textbook on it. It will give you a different perspective, and you'll learn something that you probably didn't learn before. But there were a lot of things in Gravitation that when I read it the first time, anytime they were referring to quantum or anything, I was lost. So I decided just to reread it again. And also, I want to get better mastery of the modern notation in differential geometry that mathematicians tend to use, even though I prefer the physicist notation. Another book that I'm rereading, I'm about 2/3 of the way through, is The Road to Reality by Roger Penrose. I'm sort of reading a chapter a day. I'm 2/3 through the book now. One of the reasons why I gave this book a bad review when I first read it, and if I were to give it a review now, I'd give it an even worse review. Really, the book is only comprehensible if you're familiar with most of the stuff. And one of the reasons why I'm rereading it is because when I first read this book, there were chapters where I wasn't that familiar with the stuff. And for instance, I know on chapter 15, fiber bundles and gauge connections, I wasn't that familiar with this, and so this was a useful chapter for me to review. Same thing, there are a lot of, the chapter on quantum field theory is just like horrible notation-wise and everything. And I wasn't too thrilled with the chapter on entanglement, although he has it there. He could have done a much better job, in my opinion. But anyway, I want to get back. I want to review some chapters where I'm more on like supersymmetry and loop variables, loop quantum gravity, and twistor theory, where I'm much more prepared to read them nowadays than I was when I first read the book when it first came out. Now, I'm putting together a group theory course on symmetries, and I found this course by Tobias Osborne. It's a short lecture course. It covers some of the stuff that I'm going to cover, but in a very abstract mathematical way. So I'm not recommending this to learn it, but if you just want to see some things, you can learn some stuff on groups and representations. This is a YouTube course. I think will end up being about 6 lectures, an hour and a half each lecture. Just to remind everybody, Mastering Quantum Mechanics is coming up, and I've been asked by the instructor for the course, who runs the online version, Michelle Tomasic. I don't think I pronounced the name right, but anyway, she asked me to be a TA for the course, and I accepted. So I will be a TA for the course, and the course will be, it's basically what was given before, but it will be revised to reflect the current teaching at MIT, plus the Professor Barton Zybeck's new textbook. So there's a little bit of reorganization. Some topics that were treated previously will be rearranged into 8.06, and some topics from 8.06 are like now in 8.05. So a little bit of revision, but about 90% the same as it used to be. Another course, some of you might be interested, I've been asked, 8.03, also will be running again starting in September. I don't know if I'll be a TA for this course, probably not, but anyway, this course won't change very much at all from previous versions. This is a thermodynamics of materials course on MIT X Online that's starting, I guess it's starting tomorrow. This is not by the physics department, it's by one of the engineering departments, so I tend not to be that into these courses that when they're not offered by the physics department. But if you have a real interest in thermodynamics and materials, you might find this interesting. As I mentioned before, the Computational Data Science and Physics 2 is running right now. Unfortunately, I just don't have time to go through this right now. I think I'm going to buy the course and just try for it later. It's a pretty cheap price at $49. This is the actual course, and it covers a lot of interesting things on jets and Higgs search and machine learning and deep learning on the tau particle and the W bosons. So this is for those who are interested in the intersection of experimental physics and computational physics in a particle physics context. They might be real interested in this. And of course, earlier Computational Data Science and Physics 1 ran. There's also a course which has been running for several weeks now, Math Bootcamp for Engineers, which sort of reviews things physicists should be well familiar with, but it has, if you need to review calculus, differential equations, linear algebra, probability, you might find this course useful. So that's all I have to add today. I hope to be making, I'm way behind, more quantum field theory videos and more group theory videos, and I hope to start some perhaps live broad streaming once I figure out how to do this. And thank you very much for watching, and I'll see you next time. Bye-bye.